Hello, hey there. I'm Saqib Hussain, PhD student. My PhD project is to study propagation of cosmic rays and their scan rays in the intercluster medium. My supervisor is Elizabeth Dalpino. I have two collaborators, Rafael Alves Batista, is previous postdoc student of my supervisor, and one of the collaborator, Klaus Dollig from Germany. So here in this figure I'm showing all particle cosmic ray spectrum from air shower experiments, actually many air shower experiments you can see from the figure. We are focusing on the cosmic ray energy range from 10 to the power 14 to 10 to the power 19 electron volt, and we are studying for the energy range which can confine in the cluster or which can escape from the clusters. And more importantly, our main goal is to drive the contribution of cluster to the flux of high energy cosmic rays, high energy neutrinos and gamma rays, which can be produced during the confinement of cosmic rays inside the clusters. This is my work scheme. So we are using a background MHD simulation from which we can have magnetic field and density field and temperature, and we are also considering cosmic ray interaction. For that we have to drive the mean free path of cosmic ray interaction to see which one is relevant. We consider all kind of cosmic rays interaction which are relevant and implement in the CR proper and drive our fluxes about cosmic rays and neutrinos. This is my background MHD simulation. It has 240 megaparsec cube total volume, and we divide this volume into 8 parts, and I'm showing one of the part here. Left panel show the magnetic field configuration, and the right panel show the density distribution of the background simulation of one of the portion out of 8. So here I'm also showing some profile of clusters as a sample of clusters which I consider from the background simulation. Each cluster have mass 10 to the power 14 solar masses, but at different redshift. Here you can see the profile of dark matter, gas mass, number density, temperature, over density and magnetic field. And on the right panel I'm showing the mean free path of cosmic ray interaction for neutrinos. So as you can see from green lines and the dotted red line, the green line is for proton-proton interactions, and proton-proton interaction are more dominant for cosmic rays energy 10 to the power less than 10 to the power 17 electron volt. If the energy is greater than 10 to the power 17 electron volt, then the photopion production for CMB is more dominant over proton-proton interactions. So this is the flux we got for cosmic rays. What we do, we inject the cosmic ray at the center of the cluster and let them propagate and absorb at the edge of the cluster and then propagate up to the earth. For the cosmic ray spectrum, I didn't consider any background photons while propagating from edge of the cluster to the earth. Flux of neutrinos. Here we are showing the flux of neutrinos for a cosmic ray spectral index alpha equal 1.5, and for different cutoff energy 10 to the power 17 to 10 to the power 15. As you can see, we found a best match with the ice cube data for energy 10 to the power 17 and 10 to the power 16 electron volt. All we can say, we conclude that the integrated flux for all the cluster from redshift 0.01 to 0.01 to 5 cluster of galaxies can be considered as can we count for a sizable fraction of the total flux of ice cube data. Thanks.